Okay, the second type of division that we have is synthetic division, but just to prove to you that I'm going to get the same answer no matter which division I use, we're going to review long division. And remember that you need placeholders, so I went from cubed to squared. I have 0 x's plus 10. Now x times 3 would be 3x, but I need to be 3x cubed. So I need x squared. 2 plus 1 will be 3. So I've got 3x cubed, and 3x squared times negative 2 is negative 6x squared. Don't forget that you're subtracting everybody, and 3 minus 3 will cancel. And then I have 4 minus a negative, which is really a positive. So I've got 10x squared. And bring down, yes, I will bring down 0x. That's okay. X times what will be 10x squared. I know I need a positive. It needs to be 10. But that's only 10x, so I need another x. Now I get 10x squared minus 20x. And we're going to be subtracting, so these cancel. And a negative negative is really a positive. Bring down the plus 10. And x times what is 20x? It would be 20. So we've got 20x minus 20 times 2 is 40. Subtracting, so they cancel. And a negative negative is really adding, so my remainder is 50. So that's what I need to know, and my answer would be 3x squared plus 10x plus 20, remainder of 50. Let's do that exact same problem, but now I'm going to show you synthetic, so I'm going to do it right over here. So when you do synthetic division, it's actually pretty quick and easy. So what I'm going to divide by, this is a factor, and I have to divide by the x-intercept. What would make this parenthesis equal 0 would be x being 2. So that's what I'm going to divide by. Then I take all the coefficients of these terms. Again, I will need a placeholder, so we might go from here. So I would have 3, 4, I need a 0 because there is no x, and I need 10. Synthetic division, you bring the first term straight down, and then you multiply. 3 times 2 is 6, and then you add. 6 plus 4 is 10, multiply, 20. 20 plus 0 is 20, and you multiply 20 times 2, which is 40, and when you add, that's your remainder, that last value. Now if you notice, these coefficients are the same as your answer over here. So this is what I know. I started with x cubed, so this has to be squared because I divided it, it went down 1. So my answer would be 3x squared plus 10x plus 20, remainder of 50. Or you may look at it like this. This is my remainder, so here's my constant. Then this is x, that's x squared. It comes backwards. If you notice, the two answers are exactly the same, so I've done the problem correctly. So let's work another one. 7x cubed minus 6x plus 9 divided by x plus 5. Again, you have to have placeholders. What would make that parenthesis equal 0 would be x being a negative 5. Negative 5 plus 5 is 0. So negative 5 is what I'm dividing by. My coefficients are 7. That's x cubed. Next would be x squared, and I don't have it, so I have to put a placeholder. Then negative 6 for x, and then 9. Bring the first number straight down, 7. 7 times negative 5, negative 35. 0 plus negative 35 stays negative 35. I do know a negative times a negative is a positive here, and I just put that in the calculator. It's 175. 175 minus 6 would be 160. 169. Now, again, use the calculator. 169 times -5 is -845, and you're going to add 9 to that. So your remainder is -836. So the way that I write the answer, again, this is my remainder, this is the constant, this is x, so this is x squared. 7x squared minus 35x plus 169, remainder -836. That is a large remainder, but nonetheless that is the remainder. Okay, we've got one more of these before I show you another thing they can do with synthetic division, which is simple. Plus x, no, I'm sorry, it's minus x. Hard to read. Minus x plus 7 divided by x minus 2. Okay, here's my factor. The x-intercept, or the x value, would be 2. 2 minus 2 is nothing. That's what I'm looking for. So 2. My coefficients are 2, 5, -1, and 7. 3, 2, 1, constant. That works. No placeholder. Bring down the 2. 2 times 2 is 4. 5 plus 4 is 9. 9 times 2 is 18. 18 minus 1 is 17. 17 times 2 is 34. So this is my remainder. Should be 41. Now, again, remainder, constant, x squared. So this is 2x squared plus 9x plus 17, remainder of 41. So this is pretty simple. Synthetic division isn't that difficult. But now I'm going to show you how to prove if a factor is actually a solution. So if we take x cubed plus 3x squared minus 4x minus 12, and they want to know if x plus 3 is a factor. They don't tell you that it is. They're saying, is it a factor? You have to tell them. Here's how I know. First of all, I set up synthetic division. X would equal a -3. 3, 2, 1, constant, no placeholder. 1, 3, -4, -12. Bring down the 1, multiply, add. Multiply, add. Multiply, add. Now, the remainder must be 0. The remainder must be 0 in order for it to be a factor. So my answer would be yes. In other words, what they're asking me is, does this divide evenly into this polynomial? Because I have no remainder, that's yes. This is your constant, that's x squared. So that's x squared minus 4. And it would have multiplied by x plus 3 in order to get this original polynomial. Let's do another one. 7x cubed. I'm sorry, that's the wrong place. X to the 4th minus 4x cubed minus 6x squared plus 4x plus 5. And they want to know, is x plus 1 a factor? What I forgot to say on the last problem is, since this is yes, you need to go ahead and factor this guy. Notice x squared minus 4. You should recognize as that's the difference of squares, x minus 2, x plus 2. Bring down the x plus 3 so that you have finished factoring it. So now we're going to check if x plus 1 is a factor, so x would equal -1. And my coefficient's 4, 3, 2, 1, constant. Good. No placeholder. Alright, this is going to be your remainder right there underneath your last term. Bring down the 1. When I multiply, I get -1. When I add, I get negative 5. When I multiply, I get 5. So negative 1. I get 1. 4 plus 1 is 5. So I get negative 5. My remainder is 0. So the answer is yes. And this is your constant. This is x. This is x squared. That's x cubed. So I've got x cubed minus 5x squared minus x plus 5 times x plus 1, because that's what I was dividing by. Now, you could factor this by grouping and keep going, but you can do that on your own in a little bit. So we need to do another one of these. I'm just going to turn the paper this way and do 2x to the 4th plus 8x cubed plus 2x plus 8. And we want to know if x plus 4 is a factor. Again, I'm going to use x equals negative 4 because that would make this parenthesis 0. So that's the x-intercept, and we're trying to decide, does that work? 4, 3, 2. I don't have a squared, so when I do this, 4, 3, 2, you got to put a placeholder. 1, constant. Alright, bring down your 2. I'm going to get negative 8, 0. When I multiply, I get nothing. So when I add, I get nothing. When I multiply, I get nothing. When I add, I get 2. And 2 times 4 is negative 8. Notice that this one works as well. So the answer is yes. And x plus 4 was what I was checking. It would multiply constant x, x squared, x cubed. 2x cubed plus 2 is what I would have had as an answer. So let's try one more. We're going to see if we can get a no. 3x cubed minus 2x plus 5. And they want to know if x minus 1 is a factor. So I'll be using 1. And I'm going to plug in 3. That's cubed. I need a squared. There's 1 and your constant of 5. So bring down your 3. 3 times 1 is 3. 3. 3. I get 1. 1 times 1 is 1. Hey, we finally got 5 plus 1 is 6. When the remainder is not 0, I just say no. It doesn't divide unevenly, so I don't need to worry about it. So now you can go work on your synthetic division assignment.